Hello students, welcome to this lesson. Chapter 5 Continuity and Differentiability. We have started differentiation and we have studied for example chain rule, then implicit differentiation, then inverse trigonometric functions and then their derivatives and substitution technique. Now let us first study the logarithmic function and exponential function, and then their graph, then nature, then some salient features of these two functions. Then we can apply logarithmic function concept in differentiating a very given differentiating a given function, where it becomes very simple when you use logarithmic function. That is also known as logarithmic differentiation. Therefore, this lesson consists of two lessons. In the first lesson 1, let us study logarithmic and exponential functions, then their properties. Then in the second lesson, let us use the concept of logarithmic function and their laws in finding the derivative of a given function. So these are the two major lessons. Exponential and logarithmic function. So this is the first thing we have to learn. Consider the following functions. Say y equal to 2 power x. So 2 is base, x is exponent. Therefore, it is called exponential function. Now let us draw the graph of this function. First let us find some values. Say take for example x equal to minus 2. 2 power minus 2 is 1 by 4. X equal to minus 1. 2 power minus 1 is 1 by 2. 2 power 0 is 1. Then 2 power 1 is 2. 2 power 2 is 4. So these are the 5 different coordinate values, so that we can easily draw the graph. When you draw the graph, you get the graph like this. See y equal to 2x, and the name of this function is called exponential function. So now instead of 2, you can take for example 3, you can take 4, you can take 5, like that. But you should not take 1, because if you take 1, it will be always same. So condition is that base should not be 1. You can take any other base, for example 2, 3, 4, 5, etc. And to understand the nature of the graph, it is better to take integers only, so that you can draw the graph. So I have taken one such value. Now let us proceed. So definition of exponential function is like this. The exponential function with positive base b more than 1, that is the condition, is function y equal to f of x, that is equal to b power x. Now let us try to understand the important or salient features of exponential function. First let us draw the graph once again. So you take any base b, but condition is b should be more than 1. This is the graph of the exponential function, approximate graph, y equal to b power x. Now some of the important things which you can understand is domain of this function is R, because you can see from the graph it starts from minus infinity to plus, that is from all the values, negative real value to all the positive real value. So the domain of this function is R, that means from minus infinity to plus infinity. This is the first thing. What is the range of this function? From the graph it is very clear. The range of the exponential function is R plus, even it cannot be 0. So it is R plus, the set of all positive real numbers. That is, when x is very large negative quantity, the curve almost approaches x-axis. It will never touch x-axis, but it approaches x-axis. Therefore, it is range is R plus. Then there is another interesting thing. You take any value b more than 1, and then the point 0, 1 always lies on the curve. So 0, it cuts y-axis at 0, 1. So this is another important feature. Then increasing function, you can see from the graph, the curve is always going upward. So it is increasing function. The exponential function is always increasing function, provided b is more than 1. Very important. B is more than 1. Then shape of the curve. See, for very large negative value x, the curve approaches x-axis, I told already, and never touches x-axis. For every very large positive value x, the curve, the value of y also very large positive value, and hence it is always it is away from x-axis, so it goes up. So this is another important feature. The function with base e, that is y equal to e power x is called the exponential function with base e. So this is actually natural base e. So where the e is actually an irrational number and its value lies between 2 and 3. So it's an irrational number. The derivative of x, because we are interested in finding the derivative of this, so this is d by dx of ex equal to e power x. So this is the derivative function. Therefore formula you have to remember, differentiation of e power x is e power x only, ex only. So derivative of ex is ex. So this is one important result. Next, let us take the next function, logarithmic function. See, definition is this: let b be more than 1, be a real number, and x be any real number such that b power x equal to a, that means exponential. Then we define log a to the base b equal to x. See, here the base is same, so this is the connection, b power x equal to a, then log a to the base b is x, but condition is that b should be more than 1. That is logarithm of a to the base b is equal to x. Let us try to understand this one with the help of example. So we know that 10 power 3 is 1000. Therefore we can say log 1000 to the base 10 is 3. Similarly, 2 power 3 is 8. Therefore log 8 to the base 2 is 3. 5 power 2 is 25. Therefore log 25 to the base 5 is 2. So logarithm is a function defined as follows. Therefore you can take this way: log b, that is to the base b, is from r plus to r plus to r, and x goes to log x to the base b. So this is the log function. So, and the condition is b power x must be equal to a. So this is the definition of log. Then first let us try to draw the graph. Then we shall study the salient feature. See, the graph of log function will be like this. So it is from only positive side. From negative x-axis if you take it, it will never touch negative x-axis, but it keeps on increasing, cuts x-axis at 1 0, then it goes, and it's also increasing function. So this is y equal to log x to the base e. Now salient feature of the log function you can list like this: domain of log function is set of positive real numbers, that is r plus. Then range of log function is set of real numbers, that is from minus infinity to plus infinity. Then common point is 1 0. Common point is 1 0. That is 1 0 always lies on the curve, and ever increasing, it's always increasing function. So logarithmic function is always increasing function. So these are the important features of logarithmic function. Now let us try to understand the relationship between logarithmic function and exponential function. See, the function y equal to ex and y equal to log x to the base e, they are inverse to each other. You have studied inverse function in the first chapter, that is relations and functions. So here first function is the inverse of the second function, second function is the inverse of the first function. So log, meaning log ex to the base e, this is equal to x. Similarly, e to the power log ex, this is also equal to x. So you have to remember these two important results. Now let us try to understand the graph also. The graphs are, once the functions are inverse to each other, the graphs must be mirror image, that you can see here. Say, let us take one coordinate system. Then this is exponential function y equal to e power x, and this is log function. And if you draw y equal to x, so the two functions are exactly mirror images. So this is the idea. Y equal to x, about y equal to x, they are reflection actually. That is y equal to e power x is the reflection of y equal to log x to the base e and vice versa. So this is the important result. Now important results of log we have to study, because this is required in differentiation. Log mn to the base a equal to log m to the base a plus log n to the base a. That means the function log converts the product into addition. This is one very important actually result. Second, log of m by n to the base a equal to log m to the base a minus log n to the base a, and log m to the power n to the base a equal to n into log m to the base a, and log b to the base a is same as log b to the base c divided by log a to the base c. That means you can introduce one more base, so that this is the relationship. In fact, we can prove all these things using the definition, but that is not necessary here. It is just sufficient if you remember these properties, so that this we can use while finding the differentiation of different functions using logarithmic function. So, and one more thing is formula d by dx of log x to the base e equal to 1 by x. 1 by x. So this is another important result. So today we have added two more formula to the list of derivatives. One is exponential, another one is log. Now, application of loss of log in algebraic expression. Let us try to understand how it can be employed. Well, let us say y equal to, for example, a square b cube c power 4. Suppose you take log y, then it is log of a square b cube c power 4. This equal to log a square plus log b cube plus log c power 4, because of the result log mn equal to log m plus log n. That is, product becomes addition. This is addition law. Then this you can write 2 log a plus 3 log b plus 4 log c, because of the another law, log m to the base to the power n is n into log m. So this is the law. So this is one important simplification rule which you have to use whenever you use differentiation. Next example, let me take two more. Second one is, suppose y equal to a cube divided by b power 4 c power 5. Take log, then you get log of a cube by b power 4 c power 5. This you can write log a cube minus log b power 4 c5, using the law log m by n equal to log m minus log n. Now once again you can simplify further. First one you can write 3 log a, exponential property. Then inside the bracket you see you can use addition rule, log b power 4 plus log c power 5. So this is product rule, log mn equal to log m plus log n. Then you can simplify this further. You can once again you can use exponential law here. So 4 log b plus 5 log c. Then remove the bracket. So the final answer is this. So of course these are the step-by-step procedure, but in differentiation you can directly write, taking log, write the last step. But this requires a little bit of practice. Therefore in the first lesson only I am showing you how it can be used. Let me take one more example. Y equal to, say, square root of a square b cube. So this you can write log of square root of a square b cube, but this can be written as a square b cube to the power half. So in the exponent form. Therefore using log you get now 1 by 2 log a square b cube. Using the law, log m to the power n is n log m. N can be fraction also. So this equal to now half. Use addition rule, log a square plus log b cube. So this is log mn equal to log m plus log n. So now apply the rule 1 by 2. Then 2 log b, 2 log a plus 3 log b. So this is the result. So this is illustration 3. These 3 examples are sufficient. Of course, in the last one we have used the law. Log m to the power n is n log m. So that is the. Now let us find the differentiation of a given function which involves logarithmic function as well as exponential function. All the other laws are same, that is addition rule, product rule, quotient rule, then composite function differentiation, that is chain rule. Everything we have to use here, but we are having 2 more functions, that is one is log, another one is exponential. For example, differentiate e power minus x. Now look at the function e power minus x can be taken as a composite function. So let us see how we can differentiate. Let us take y equal to e power minus x. Therefore, using chain rule, dy by dx equal to d by dx of e power minus x. This is e power minus x into, we have to differentiate minus x. So it is minus 1. Therefore, e power minus x into minus 1. So it is minus e power minus x. So this is the first one. Second one, differentiate sine log x. Of course, whenever we log x means base is e, that is what you have to understand. Of course, condition is x should be positive. Log is defined only for positive reals, that you have to remember. So with respect to x. So now let y equal to log sine x. Therefore, using chain rule, dy by dx equal to d by dx of sine log x. This equal to cos log x, because differentiation of sine is cos. Then what you have to do is chain rule, d by dx of log x. Therefore, this is cos log x into differentiation of log x is 1 by x. So this is the answer. So cos log x divided by x. So this is dy by dx. So this is a second example. Next, differentiate cos inverse e power x with respect to x. So same thing, let y equal to cos inverse e power x. So using chain rule, dy by dx equal to, first one you have to differentiate cos inverse x, that is minus 1 by square root of 1 minus ex square. Then what you have to do is differentiate ex, chain rule. Therefore it is minus ex divided by 1 minus e power 2x. Now let us take exercise 5.4. There are many questions on this function only. Example 1, differentiate e power x by sin x. So with respect to x, of course here we have to use quotient rule. Therefore let y equal to e power x by sin x. Therefore using quotient rule, you can write d by dx of sin x as it is d by dx of ex minus ex as it is d by dx of sin x divided by sin square x. This is quotient rule. Now this simplify, sin x into d by dx of ex is ex only minus ex into differentiation of sin x is cos x divided by sin square x. Of course this you can simplify. So this is ex common, sin x minus cos x by sin square x. You can keep the answer here only. Or you can take, for example, sin x by sin square x, then cos x by sin square, etc. You can simplify like that also. But I am leaving the question here only. So this is the answer. Next, example 2. Differentiate e power sin inverse x with respect to x. So let y equal to e power sin inverse x. So this is definitely a composite function. So you have to use chain rule. Therefore, using chain rule we get dy by dx equal to d by dx of e power sin x. First you have to differentiate with respect, so e power sin x is e power sin x only. Then we have to differentiate sin inverse x. So this is e power sin inverse x into differentiation of sin inverse x is square root of 1 minus x square. So this is e power sin inverse x divided by square root of 1 minus x square. So this is the answer. Next one, differentiate sine of tan inverse e power minus x. Look here, this function is composite function of 3 functions. First e power minus x, then tan inverse, then sine. In fact, there are 4. First x goes to minus x, then e, then tan inverse, then sine. So let us see how we can do it with respect to x. So let y equal to sine of tan inverse e power minus x using chain rule. First sine becomes cos of tan inverse e power minus x. Then once again you have to differentiate d by dx of tan inverse e power minus x. Therefore this can be written as cos of tan inverse e power minus x. Then differentiation of tan inverse x is 1 by 1 plus e power minus x whole square. Then into differentiation of e power minus x. So 3 times you have to use actually chain rule. Then first simplify the first two. What is the differentiation of e power minus x? E power minus x into once again d by dx of minus x. So the final answer is cos tan inverse e power minus x 1 upon 1 plus e power minus 2x after simplification. Then e power minus x into minus 1. So if you want, you can simplify this one further so that this is the final answer. So this is fourth example. See, there is no difference. Only thing is we are adding two more formula, exponential function and log function. Then all the remaining rules are same. Next, example 5. Differentiate log of cos ex. So with respect to x, same thing. Let us take y equal to log cos ex. Then using chain rule, you get dy by dx equal to 1 by cos ex. Log 1 by differentiation of log x is 1 by x. So 1 by cos ex. Then once again you have to differentiate d by dx of cos ex. So this is 1 by cos ex into minus sin ex into, once again you have to differentiate d by dx of ex, chain rule. So this you can write minus tan ex, because minus sin ex by cos ex is minus tan ex, into differentiation of ex is ex. Therefore this is minus ex tan ex. So this is the answer. So next one,